Okay, welcome everyone. A nice full room for this session on computational creativity, with already a very nice provocative subtitle. Can you be as creative as kids? Looking forward to that. My name is Noordegraaf. Welcome to this CREATE Salon, a series of seminars where we discuss work in progress on anything related to humanities and computation. My role is very short. I just want to introduce and welcome Fabian, who, as part of the CREATE team in the past period, has programmed this theme and this salon. So I gladly hand over to you.
Yeah, thanks also. Welcome from me. I also will keep it very short. But I just want to mention kind of the idea or why we decided to organize a salon on this topic. And I think the main reason is that we all know that developments in computer science, machine learning, and all of these buzzwords have been very rapid and astonishing in the recent years. And alongside this development, we discover often that it's not only a technical development, but actually that this development raises certain questions about what we consider to be the relation between machines and humans, but also more self-reflective, what we consider ourselves to be, or our capacities. Can machines be like humans? Can we be like machines? And all of these questions are, a bit messy sometimes, but highly fascinating, I think. So we decided to organize this event, and I'm very, very happy about the speakers we got to come here because they will approach this topic from very interesting angles. We have some more theoretical approaches, but also lots of practical examples. And I think this will kind of fuel our questions and discussion. And so let me directly introduce our first speaker, Christoph Finkensiep, who will speak about what's for dinner, apparently. Christoph recently defended his PhD at École Polytechnique Fédérale de Lausanne in Switzerland in digital humanities on a topic of computational musicology, where his main research area is. But he has also lots of other interests. So he has a background in cognitive science and computer science and a strong interest in philosophy. And all of this he will maybe bring to the table and maybe give some ideas to an answer to whether humans can be as creative as machines. So welcome, Christoph. Thanks a lot.
Thank you very much. So as Fabian mentioned, I'm usually working on computational musicology, which some people would say has probably something to do with creativity, but I'm not really a creativity researcher as such. So the ideas and thoughts that I would like to present here today, they mainly come out of discussions that we had in our lab, and a paper that came out of these discussions, and then some other thoughts that I like, use to complement this. So
I see it.
it's
okay, sorry.
It's not on there, but
I see it. Yeah, I don't know why I don't see it actually,
but it's okay.
I see it on mine. Yeah.
Okay, so let's hope for the best. So the question I would like to discuss today is one of the you could say fundamental questions of humanities. I'm sure lots of you had the same question as well many times. What should I make for dinner? It's usually very tricky, and if you like me, then the answer will amount to something like this: you buy a big pack of ravioli and like alternate between different variations of the same dish or something like that. Of course, there's also a different end of the spectrum here. And people who are probably most qualified to invent dinner ideas are the contestants on cooking competition shows on TV. So maybe you know some of these shows. People go there and get some kind of topic or maybe some ingredients that they have to use, and then they have to come up with a nice idea and cook it and eat with these things. So those people are much more qualified to decide like what should we make for dinner, right? Like they probably have better ideas. So for me, the natural question is, can I teach the same thing to a computer? Will the computer ever be as creative as these cooking show contestants? So we can reduce the problem to a simpler problem. Okay. So when we think about humans versus machines or computers, we tend to focus on the difference between them, right? So humans on one hand are seen as something like natural, they are alive, and they kind of work based on biological mechanisms. And on the other hand, machines are not really considered alive. They are artificially created, they are designed for a certain purpose. And they work based on different principles, right? Like mechanical or electronic principles, right? But fortunately, if you go to a cooking TV show, then it doesn't really matter who you are, it matters what you do. In other words, we're not interested in what these mechanisms are, we're interested in their behavior. So how can we describe behavior? One of the ways of doing this is to look at the relation between inputs that go into a mechanism and then the outputs that the mechanism produces. So in our case, inputs would be something like ingredients that somebody has available, so like the stuff that it has in the fridge. Maybe some kind of ingredients it has to use for the challenge, right? And then maybe the topic of the week or something like that. And then we could try to see, okay, like based on these inputs, what are the recipe ideas that people can come up with? And we characterize this relationship as a function that maps the inputs to the outputs. So if we use this to capture human behavior, it's maybe a little bit underspecified, right? Like based on only these inputs here, people could come up with completely different ideas. We could add some more inputs, be more precise. It probably depends on personal preferences of the cook, what they know about cooking, what they believe maybe the jury would like to see. But also maybe the current mood they're in, or like the current weather or the season of the year. So all of these kinds of things might play a role into determining what recipe idea the contestant will eventually come up with. But the thing is, at some point we have listed like all the possible things that could play, right? Like our brains eventually produce these ideas, right? And they do that based on their internal state and their environment. So eventually there is this kind of function from some kind of input and environmental conditions to the actual recipe idea that's produced. So the good news is, if we know this function, then in principle we could build a machine that computes this function. Right? So in principle, on some level, we can consider the behavior of humans and the behavior of machines as something that we can compare. Okay? And on some level, we can say this machine does the same thing as human, at least for this problem. And then Mark calls this the computational level of description or of analysis. On this level, we are concerned with what happens. We could also be a bit more specific and talk about how this could be done, right? Like, is there some underlying algorithm that computes this function? We'll see if the kind of algorithm that the human brain uses to compute this is similar to the algorithm that the computer uses. Right? So even on that level, we could match the two mechanisms. What we don't really get together is on the physical implementation level, right? Like computers, as we usually use them, are like electronically and work on electronic principles, and brains on biological principles. So maybe on the physical level, they are still different, but we don't really care for this purpose here, right? Like here we are mostly concerned with behavior, which lives on the computational level. Okay, so question answered. Yes, computers can be, in principle, they can in principle do exactly the same things that humans can do. But is that really all there is to say when we talk about creativity? So usually in this context, there are two main objections to this, like to this principle possibility. The first one is that when we build a system, is it really the system that is creative, or is it the one who designed the system? Right? Is it the computer or the programmer who's actually doing the creative work? And the second objection is that it seems like these like design mechanisms, they just like follow instructions in a stupid way, right? Like there's no kind of inspiration or there's no kind of will for like actually making creative decisions or something like that. So maybe humans have something essential that computers don't have. So let's look at these two objections in turn. So when it's about the problem of is it actually creative, the designer or the program itself, the idea is kind of that the program in a way only does what it's told to do, right? So the conclusion drawn from that is that the programmer has basically already done all the creative work, right? And the program, the execution of the program is just some kind of automation, right? It's not really doing some extra work. So that would suggest that the programmer already knows kind of what's going to happen, right? They designed the system for a certain purpose. That's how we usually design machines, right? Like we design them for a certain purpose, and they are well designed if they satisfy this purpose, right? But in many cases, this need not be the case, right? Like we don't necessarily know what the outcome will be. There's different ways in which this can happen. So here's a little example of a creative program, or maybe creative program that comes up with new recipe ideas. So the first step it does is doing a complex physical simulation, right? The problem with these kinds of simulations is that they are chaotic, but they can be chaotic, which means that there's not really a shortcut to determine what the outcome will be. We actually have to run this simulation to see what the result is. So a programmer who writes something like this doesn't know how the result looks like, right? Like we have to run this function in order to see what the result looks like. Even though everything here is deterministic, right? Still, we can't really take a shortcut here. The second way in which we might not know what happens is if we use some kind of input data and learn from that, for example. So it's actually often the motivation for using machine learning that we don't know how to do something explicitly, right? Like if we categorize images, if we already knew how this works, then we wouldn't have to use machine learning to do this. Right? We use machine learning because we think there's some implicit knowledge in the data set that we can extract, so that we don't have to like explicitly write how these different categories of images look like. Right? So in that case, we also don't know in advance what exactly we will get. Right? And we couldn't do it by hand, right? Like we can only do it by using this route, basically. And the last option is, of course, to introduce some kind of stochasticity, or probability. To make random decisions, and then of course we can't know what the outcome is. Right? Like, we might know the distribution, but in combination with the other things, we can make it so complex that we can't even like imagine the distribution of the outcomes. Right? So if any of these here happens, then we can't really say that the programmer already knew what would happen. Right? So there's some considerable work to be done by running the program, right? Like it's irreducible in a way. We can't just leave it out. So this would be a possible response to this objection that the programmer has basically done all the work already, right? But maybe this enforces the second objection. Like here, the program is just following some stupid steps, right? Like it's not really doing anything on its own. It just does what it's told to. So maybe for creativity, we need something more. We even need some way of actually deciding something. Here, the program doesn't decide anything, it just follows the steps, it flips a random coin, right? Like this is just random, it's not a decision. So how does this? Yeah, this brings us to the second objection. That there is supposedly something that humans have to make these creative decisions that computers don't have, right? Like for computers, it's for us easy to imagine that they don't have this. Like we can't really see the agency in the computer, right? For humans, we tend to believe that there's some kind of agency, right? Like we think of ourselves as beings that can make decisions, right? So how to respond to this objection? Like one possibility is, of course, to just deny that there's a problem, right? Like there's no soul or free will, or like it's all just a biological machine, right? Like the brain is just a computer and that's it, right? Like why should show me where the agency comes from, right? That's kind of the easy way out. But there's also a second way of responding, which is that for creativity, it actually doesn't matter. And that's what I would like to look at a bit more closely. And now we have to get to the point where we have to like, think about what creativity actually is, right? Like we always end up at this point. I don't want to give a precise definition here or review definitions or something like that, but there's a surprising consensus on two essential features, which is that something is considered creative if it's in a way new and in a way good or useful. Okay, so can we look at these things, or can we make these ideas a bit more precise? And I tried to do this in a recent paper. And he says that, or like his idea is that the quality part can be modeled as some kind of evaluation function. So basically there's a function where we put in our creative object or like the product of a creative process or something like that, and will give us some kind of quality rating. But this evaluation function is very much dependent on the specific problem that we're talking about, on the context that we're in and so on. Right? So it's not just one thing that we know, it's completely context dependent, right? The second property is that it's hard to find good solutions. This is also something that we know from other parts of computation. We have a function that we know in principle, like a loss function, right? But it's very difficult to find actually a good solution. Right? And the third property is that this evaluation function is sometimes known explicitly. For example, when we play chess, it's very simple, right? Like if the move makes us win the game, then it's good. If it makes us lose, it's bad. It's still difficult to find good moves, right? So that doesn't exclude the hard to find good solution criterion. But in some cases, the function is not even known explicitly. And one of these cases is cooking, of course. Right? It's not like we have a function where we can look up which recipes are good, right? But usually we have to kind of apply different tests, right? Like for example, we have our jury here from the cooking show who's presented with a dish and tries it and says thumbs up or thumbs down. Or we could go to marketplace and ask some random people if they like the product. So simply tasting, right? And they would, for example, use different criteria, right? Like in the cooking show, it's maybe about how well it satisfies the topic or something like that, right? And here it's more about like, do people like it? Is it something familiar? There are two different contexts, so there are two different evaluation functions. Or we could have something like a review website that's like reviewing the worst or most crazy dishes from recipe websites or something like that, right? Again, different contexts, different criteria, different evaluation. So just to make this a bit more visual, we can imagine this as some kind of space. Oh, I have to find my cursor. Here it is. And so every point in the space is a possible solution to the problem. And this evaluation function here tells us which of them are good. So how do we deal with the second criterion of novelty? This is a bit more complicated. But here the idea is that novelty is again relative to something context dependent, which is in this case a set of known strategies. Right? So known strategies we can imagine as kind of regions in the space that we already know, that we've already explored. And these really kind of explain a new solution, or they don't, right? Like if I give you a new solution or a new recipe, and you can identify that this supposed to show here is. So we have like different regions that in the cooking case, for example, would correspond to known recipes or kind of classes of recipes, right? Like we have a broad category of stews, we have sandwiches, which includes maybe something like burgers or something like that, pizza, salad, right? Like these kinds of meta recipes. And then we can see that we can be creative in relation or like create something novel in relation to these known strategies in different ways. Sometimes it's just combining two known strategies, right? Like pizza burger is a kind of combination of sandwich and pizza. Or something that's like just outside of what we would normally consider a known strategy, right? Like so, I think there are some debates about whether these are not. Or it could be something that's not novel at all, right? Like we have the class of salad and potato salad is just a very known thing. That's not really new. But it could also be something that's completely outside of our known reference frames. So it needs to be somewhat novel with respect to these strategies. And sometimes it's something that is not covered at all by any of these strategies. Sometimes it's just that within a known strategy, we make some kind of new turns, right? And then it's maybe just a little bit novel, but still some kind of creative work. Okay, so this is kind of the reference frame. The important thing to see here is that it's all very context and problem specific. Right? There's no single definition that fits all creative domains. Okay, so what can we now learn about creativity? What does it mean? So one of the insights here is much more important what the outcome is than how the process looks like. So this is important for the artificial creativity aspect, right? We don't really care how we get to this result. What matters is how we judge the outcome in the specific context setting, right? Like how we evaluate it with the evaluation function and how we judge its novelty relative to known strategies, right? We still learn a little bit about the underlying processes. There might not be a single unifying creative process. There might not be a certain, like brain region that is responsible for everything creative that we do. It's actually pretty unlikely because we can apply it in all kinds of different domains, right? But we know that it certainly has something to do with exploration. Right? We need to kind of get away from the known strategies. However we do that. And probably it also requires something like an internal measure of quality. We could in principle go without these things, for example, just randomly sampling from the space, but we would get very inconsistent results. If we want to have somewhat reliable results here, then the system to some extent needs to take these two aspects of exploration and quality measure, at least implicitly. And the last point then is to see that the system itself also must be to some extent problem aware, either because it's specifically created for a purpose, like a chess engine, for example, or because it's something generic, but then it kind of needs some information about the context in which it's applied. So very high level, but still we learn a little bit about the mechanism. There's one interesting dilemma that's coming up now, which is if we talk about computational creativity and artificial systems being creative, then if we create these or if we build these systems on our own, isn't the system itself a known strategy already? So isn't there some kind of feedback that would actually through the back door prevent artificial systems from being creative because they're always a known strategy? And I think this is related to the earlier point about the predictability and the kind of intention of the design. How much is the programmer doing? How much does the program do? Right. So in a way, if the program is sufficiently mysterious about how it actually produces the results, it can be perceived as creative. If we understand roughly what's going on and roughly how it gets to the results, we won't judge it as creative as if we don't know this. It's also a matter of audiences, right? Like if we have an audience who understands what's going on there, they might judge the outcome differently from an audience who has no clue what's going on there. So, okay, second time that we've actually answered the question, right? Like, is it possible? Yes. Do we have to deal with these objections? Well, we have found several ways of getting around these different objections. So it seems that it's possible. But possible doesn't mean it's actually doable, right? Or it's actually easy to do. And so what is needed to reach the human level? So how can we actually build a program that can like create these kinds of fancy recipe ideas that the show contestants can create? And I won't give an answer here, but I just want to show some points because of which it might be more difficult. And the problem here is not so much on the side of creativity as such. The problem is more on the side of the domain in which it's applied. And the domain of cooking has a lot of subtlety and a lot of like very abstract concepts that play into how we judge these outcomes here, right? Like how we apply this quality evaluation function. So one thing, for example, is that we don't want to, like that we are looking for some kind of intention behind some kind of idea that's underlying the recipe. If we think that people just threw together random ingredients, we don't really consider this as something well thought out, right? So some kind of intention is something that we're often looking for in creative domains. Or it can be something that's very much related to personal experiences. right? And this is very difficult to model for a computer program, right? So it's like a very complex psychological phenomenon that is like at work in this particular domain. The same goes for things like lifestyle trends or like some kind of self-identity. This is something that when we think about recipes plays a big role, right? Like many recipes or meals have some kind of connotation in terms of and a certain image that's communicated, something like that. It can impact or like there can be an influence from moral aspects, right? Like if we don't want to eat meat or something like that. And finally, it's also something that can signify social status, right? So we have all kinds of cognitive and social interactions that we have to consider when like trying to model this kind of quality function here, that in practice makes it extremely difficult to get to the human level here, right? But again, it's not something that's per se on the side of creativity. It's just because we apply the concept of creativity in a very complex and cognitively and socially domain. So what are the things that we can learn in general? Creativity is probably not one single unified mechanism that we can somehow generally influence across all domains. And like you might maybe get it from TED Talks or something like that. But it's a phenomenon that occurs in all kinds of different contexts. Right? So if we think about it as a phenomenon, as something that happens, so it's, in a way in how the audience views something rather than in how it comes about, then maybe this is a better way of looking at it. So with respect to the title of this session here, creativity as the final frontier, right? At least when it comes to cognition, maybe it's not really right to say creativity itself is the final frontier. It's not really like the problem that we have to solve in order to solve cognition, but it's kind of the other way around. It's that all the interesting problems where we find the phenomena of creativity are domains that are really, really complex and difficult to explain from a cognitive modeling perspective. So in a way, it's everywhere around this final frontier of us trying to understand how the mind works. Or the same would go for culture, right? Like trying to understand how culture works and how maybe social phenomena work. And the final insight is that it doesn't help us at all with dinner plans. So I guess I'm back to thanks for it.
Thank you.
So I didn't mention it in the beginning, but so the general structure is after each talk, we have some time for immediate questions. And then at the end, we have some maybe time for, mingling all of these thoughts together. And I suggest we start here in the room. And then we open also the floor for questions from the online participants. So, Fabian.
Thank you. It's very clear and inspiring. And I was struck by what you said about this distinction between the process and the result. I think you make a case that it is sort of looking at the result, but I wanted to push back a little whether it is actually the process that is what creativity is about. And I'm doing so because the aspects you gave, why it is so difficult to do so, like trends and morals and culture, that is very often changing. And I think you mentioned that there's deterministic and stochastic aspects to the function you showed. But isn't the stochastic exactly what makes it a process and what makes it? Because if it's deterministic, then you have the input and you have the output, and basically what you're interested in. But isn't the stochastic aspect what actually makes it interesting and makes it an aspect of culture? And so why this clear distinction? Basically, my question.
I think there's like two things to distinguish here. Like one is the process that, like this kind of assumed process that produces the creative result. And of course, there must be some kind of process there, right? It's usually not just there, but I mean that's why we call it creative, because it's created. Like it was not there before, and then it's there. So there was some process that kind of generated this result. That's kind of on one end. And we know a little bit about the process, right? But we don't really know, we don't really care about all the details in there. And whether it's stochastic or deterministic, I would claim that that doesn't really make a big difference, right? Like the kinds of variations we often get from the inputs. Right? Like if you think back to this long list of inputs for like how humans come up with the recipe idea. A tiny variation there might already lead to like a big change in the outcome. But the other thing that changes, and which you can also call a process, is the environment, of course, right? Like so when you say these contexts change, and I think what changes here is that it's not really you don't really map it to the process that generates the result, but what changes is the context with its quality evaluation function and known strategies. So, for example, I don't know, like 10 years ago, avocado sandwiches were a big thing, right? And nowadays they're probably still a big thing, but we think about them a little bit differently because now we see the trend, right? Like, or burger restaurants. So the way we look at this and the way we judge the outcomes is what changes. And in a way, of course, the process that would act in this environment would have to adapt to this in a certain sense, right? But it's kind of orthogonal, right? Like you can think of this kind of inner process as like an inner loop that just like runs once in a given fixed environment to produce a result. But then once the environment changes and you run it again, it might do something else, right? But it's kind of a different instance of the process. Does that answer the question, or?
Yeah, I think your answer to me separates creativity and sort of creative output in a way. So for me, creativity would be the process itself.
Which of the processes?
The process that if the context changes, the outcome changes.
Okay.
So you could give me an avocado sandwich in the 80s and you could give it to me now. And I guess they're separate things, but going from the 80s until now, that to me signals creativity in culinary tradition, basically, to go from one point and responding to how things change in a very complicated manner, as you clearly shown. But that in itself, to me, is creativity in cooking, and not pinpointing a moment and giving me an avocado sandwich and me saying, "Oh, that is creative. I need this domain knowledge to be able to assess it as a creative, as something coming out of a creative process."
Yes, I think like I mean in principle this kind of domain knowledge is encoded here in a very abstract way, right? Like in these evaluation functions and so on, and in this case particular also the strategies. And this is something that's not really characterized more closely here, right? So it's kind of avoiding the details of this, but you're completely right. Like this is where the interesting stuff happens.
So I'm wondering if I can ask you to do a quick on-the-fly case study, just to help understand this model of creativity better. And I think of David Cope. Do you know David Cope? Maybe not everyone here does. So my summary, feel free to disagree, but I mean, David Cope, one of the first, I would say, very, made a splash, in the world of what was seen as computational creativity in the early 90s. And what David Cope basically did was chop Chopin up into little pieces, wrote a very elaborate and quite clever rule-based system, putting pieces of Chopin back together. And then everyone was very happy that the results sounded a lot like Chopin. And you can look at that very cynically and say, well, what were you expecting if you chopped Chopin up and put it back together again? You can also look at it as like, just putting Chopin back together again is actually far from a trivial problem, and is actually quite difficult, to do, and indeed maybe isn't even so far, from a compositional process where you have a particular style and then kind of things. And so just from the perspective of this theory, without trying to judge David Cope, who's very influential, doesn't really need sense anymore, were these Chopin pieces that David Cope's system created, was that creativity according to this model, or maybe more interestingly, where is it creative according to this model and where is it not?
I mean, this model, it doesn't really tell you what is creative or not, right? Like in particular cases, it's more like a conceptual framework, right? So you could now try it to say under which conditions would this be considered creative or not. But these conditions then like give details about, if you stay in this framework, would give details about the evaluation function and node strategies. So, for example, you could say the quality aspect satisfied depends on whether you ask like random people on the street and they say, yeah, that sounds nice. Or if you ask a music expert who says, yeah, that doesn't like make sense, completely out of the style, and here like all the details are wrong. And this is often a big question in music, like computational music generation, right? These kinds of questions. On the creativity side, the question would be if these outcomes correspond somehow to something that we've seen before. Like do they look formulaic or something like that? Like do they follow kind of a known schema or recipe? Or are they like sufficiently far away from these chains to be considered creative? I think in the musical case it's probably very simple to get away from this, at least on the computational side, because like every little detail change is kind of a deviation. It's something that's non-trivial actually to decide. If you only repeat like a four-chord song, there's many instances in which you follow just the recipe and this is creative, considered as not creative. But even if you use like musical schematizes on very like, or just cadences, right, like that are very typical and always kind of look the same. There's just so many different ways of combining them that the extra decisions that you have to make to turn these recipes into a full piece probably already justify some kind of novelty. Right, or striving some kind of novelty. But yeah, the theory doesn't really tell you anything more specific than that, right? It's more like a reference frame or maybe like a coordinate system for bringing in your own judgments and like make it a bit more clear maybe. So.
And what did you think yourself, Ashley? What is your opinion on these pieces?
You're living with your friends, they would go. I think it's actually a good example of times changing, honestly. Like I think in the early 90s, it was really impressive. Even then, I think there was criticism that, that it's, maybe, wasn't creative enough. But again, like the point was, of course, I was surprised that we drop up Chopin. It sounds like Chopin when you put it back together. But I think people did sometimes underestimate how hard that was to do, especially with the tools that we had then. But if you put up a David Cope composition compared to, say, like AI swing contests that I co-organized and look at the best entries now, I mean, yeah, it's hard, to look at that and think that that was, the height of creativity. It's very, very, very clever prestige work. But it for me, at least, feels like it kind of falls short. And I think for me, it is the, and it's hard to define where you have this, but I think for me, it's like there needs to be more creativity than just transition, from one, kind of pre-existing thing to the other. There really needs to be this idea for me. That, okay, but you've actually created some, not only are you putting things together in a clever way, but some of these little kernels that you're pasting together are themselves by some metric novel, I guess on that. So that would be my personal view, but that's personal. There's very much room for debate there, and it's.
I see there are two questions in the chat.
No, that's me. That's me repeating the questions for the
Great, that's great.
people at home. Yeah.
Next question. Could I ask you to give a short answer so that we can then switch to the next speaker?
I hope that okay, because I think it's kind of a common question, and I'm kind of new to meetings and also like discussions on creativity that you maybe had, so maybe with me you already like I don't know noticed, but I think it's quite interesting because for me creativity is something that you actually have a desire for, an inner desire as a human being. Like that notion when you talked about the creative spark, I think that's exactly the interesting thing, because it's fun for us to have these sparks and these moments. That's why we engage with it. That's why it's amazing, and it can be very trivial, the output for one person and for the other. But what is so fascinating is about practicing, like doing it and being creative, right? For us as humans. I just wonder, because if we start thinking about our machines or computers creative, like, I mean, we don't think about, are they having, like, is it something necessary that they want to feel or what they want to do? But for me, it's more that I think about how does that change our practice of creativity? Like, how do we yeah, how do we act with the machine and so on. And then I was also thinking about these rule-based and or explicit approaches in comparison to implicit approaches, because I think there's also like this nuance in how you engage with designing creative machines, which makes definitely a difference for your own practice. You know, how you engage with that, and you would I don't know, consider, for example, explicit systems more more rich in being creative for us as humans than implicit systems, or the other way around. Yeah, I don't know. What about it?
There's some connection to this kind of like how much creative work is done by the designer and how much is done by the program, right? But I think you get the full spectrum there, right? Like you can do something that's like conceptually very trivial, right? Like it's like just chopping up things and really like randomly reassembling them, for example. It's not a big crazy idea, right? So maybe that's not like very satisfactory to do from a human perspective, right? I mean, this was very much from kind of the outside perspective, from the observer, and judge if it's great from us, so it doesn't really touch the things. But other than that, I completely agree with your points, right? Like the we do this because we have fun. And I think there's many different ways in which we can do this together with machines, or using machines, or in some kind of interaction, right? Like it doesn't need to be the machine doing something completely on their own. I think there's plenty of examples where like we have this kind of co-creativity thing that you have kind of feedback loop between machines. And of course, already the design of a program is part of this feedback loop. Yeah, I don't think I can say something more specific on that, but I agree with your comments.
Great, then let's get Christoph. Switch machines.
Yeah. Have you tested before?
Maybe try again. The HDMI also running about the second time.
Yeah.
Yeah. Unplug. Yeah, it's for me. Ah, there it is.
Great.
Okay.
Yep, it's on.
Great. Our next speaker is Phipps, our in-house contribution to this event, so to speak. She works as coordinator for the CREATE project, but is also involved as a research assistant for the Ksenia media suite. She has a background in, sorry, I have to look this up, contemporary art and cultural theory, as well as media studies. So you have a very different angle that you'll hear here this speaker series, but also different kind of from the approach that we'll take, if I understood it correctly, that we'll see also a lot of practical examples, how people engage with computational creativity or engage creatively with computation. Thank you.
So I guess on the computational images, iterations, which are some sort of perceptions. And so I kind of want to just start off with kind of, yeah, I just kind of want to start off with one of the most recent AI generated works that was just recently begins exhibition at the New York. And it's called Unsupervised Machine so basically the artist Anadol usually works with site-specific public art projects that use parametric data and kind of immersive installations. And so it kind of ends up trying to explore these spaces between the physical and the non-physical or the digital realm or entities, and doing so by using data-driven machine learning algorithms. So it kind of ends up trying to explore these kind of hybrid relationships between architecture, media arts, and machine intelligence. And so he usually asks these questions such as, can a machine dream? Can a machine hallucinate? And so you can see kind of directly in this installation, he generates what he refers to as these machine hallucinations that are made from a data set consisting of MoMA's entire archival collection. And he kind of explores this data set using what's called a UMAP algorithm in order to reduce the entire dimensional complexity of the MoMA archive, looking for the similarities in the artworks for resulting in what he quote unquote calls a data universe. And the technological system that this runs on specifically is generative adversarial networks, also known as GANs, which are programmed to preview all the images, in this case, the MoMA artworks, to produce these kinds of visual associations between them in order to learn and create what you end up seeing on the screen. So in turn, Anadol kind of explores questions such as, how is our experience of space changing now that digital smart objects and urban screens have kind of embedded themselves in our lives, and how has media technologies changed our conceptualization of space? And how has art and architecture embraced these shifting conceptualizations? And so these are now kind of the themes I'll try to explore as well, to see what other artists are doing with that as well. So Anadol's questioning of if machines can dream or hallucinate is not necessarily something that's new in the arts and futuristic sciences kind of realm. This work is by a French artist, Philippe Paranot, and it's called The Owl in the Daylight, which is the title of an unfinished novel by a very prolific science fiction writer, Philip K. Dick. And it was actually unfinished because it was what he was writing at the time of his death in 1982. So the work is basically conceived entirely in computer-generated imagery, and it's deemed as a kind of work in motion that's depicting a landscape and a body of water, because the work in motion, in quotes, is because at first when you're there, it seems static, but it's actually is moving in a very slow kind of generative fashion, because it's composed of these multiple visual sequences that are combined using what is called bronze technology, which the artists, musicians, and scientists came up together, which is a form of artificial intelligence technology. So basically in this work, the AIs control the animation and the soundtrack of the film, creating what the artist describes as an autopoetic system, responding to itself and its surroundings endlessly. So it kind of bases itself on this cybernetics framework of feedback systems, kind of dealing with these systems of communication and control, visual, sonic, adaptive systems that can kind of come to terms with unexpected terms through feedback of kind of getting along. So essentially, Paranot kind of uses the space of the museum and the exhibition and the white cube to kind of like explore the black box of artificial intelligence by playing with the spatial boundaries and the sensorial experiences of the viewer. So it kind of brings questions to the forefront, like if computational architecture and design have kind of made the experience reduced to the space through an aesthetic form of coding, then the interactivity has kind of reduced this experience to this feedback, then the algorithm aesthetic kind of becomes more physical and people kind of sense it in a more visceral way. So the next section I'm dealing with is the real and the virtual space. So basically, it's not only artists and writers that have been exploring these kind of spatial and sensorial dimensions of artificial intelligence and experience and consciousness as this kind of like technological exploration in a science fiction context. It's also tech companies have been doing this as well. So one example is the what was created in 2015, the Deep Dream Generator, which consists of artificial neural networks, which is a style of computing inspired by the brain and the nervous system. And it's used in order to learn to recognize shapes and pictures and highlight which features are being activated when the processing an image. So it's kind of intended to show how the machine interprets. So essentially, deep learning uses data classification, identifying items in a photo or tagging people, but it does so through edge detection, which you can kind of see on the left-hand side here. And that's a fundamental of image processing, right? So then what the Deep Dream algorithm does is it kind of transforms that skill set of the edge detection into these kinds of what people refer to as like psychedelics or psychedelic quilts to flip the system around and showcase in a reverse how it does its edge detection. So it kind of highlights all of the things that it is typically looking out for. So, and then what's interesting is the more images that you feed into it, the more kind of strange and interesting the deep dream generator images become. So a lot of this kind of neural networks is not necessarily new. It was kind of theorized and implemented in previous decades, but this kind of explosion in deep learning, like the generator, was mainly due to innovations in graphics processing units. So graphic images, which allow for the increased production of synthetic data. And synthetic data is just essentially computer graphics and 3D game consoles and things like that. And those are used specifically to also train these machine learning models. Most of them you need specifically to have kind of photographic images and synthetic data in order to test if the models are actually able to distinguish between the two. So it kind of, and it also is much more useful to use synthetic data because it's cheaper, it's more, the segments are cleaner, richer, and photographs aren't necessarily that way all the time. So So basically what's happening right now with media scholars is that they're kind of pointing out that these deep neural networks, like in Google Deep Dream, are exploiting the local spatial correlations that are present in images, like in the edge detection, and then showcasing that exploitation of those spatial correlations. And then they're kind of growing in their robustness in terms of being able to understand what that depth is in scale. So basically, in contrast to contemporary media scholars, the kind of cultural theorist and the urbanist and the architect and aesthetic philosopher, Paul Virilio, kind of demarcates this shift that the media scholars are talking about as a shift in perception of what is deals with kind of the real versus the virtual. And it concerns spatiotemporal coordinates that begin with the invention of video recording and computer graphics. And he says that this leads to the growth of this market in synthetic perception and all the ethical questions that entails and the preparation for what he calls the automation of perception. So the automation of perception basically just deals with the delegation of an analysis to an objective vision machine. And it's based on three core factors. One of them is spatiality. So it's tracking the moving human or objects within the environment, usually from multiple different camera perspectives. Then there's temporal and sequential memory. So it's being able to recognize activities in image sequences or sequences of images. And then also anatomical, of course, so trying to recognize the motion of body parts that are moving. And he kind of says that this shift calls for a need to have a look at another look at the virtual image. And so what I have here is a work by Alan Warburton, which is called RGB FAQ. And in this work, he kind of does exactly that. He kind of takes a very critical look at the nature of the virtual image. It's a video essay, but it was also a 3D projection mapping and sculpture multimedia installation that was commissioned by the Arts Council in England. And so basically in the video essay and in the exhibition, he explains this history of the synthetic data and how within the field of computer generated imagery, there was massive strides taken to use two-dimensional pixels to represent 3D information. So, and that was primarily done with the implementation of a wireframe. And he says that the basic question that comes down to the implementation of the wireframe was programmers trying to deal with the question how to intuitively represent massive amounts of spatial data into a 2D image. So, and with the introduction of the wireframe, as well as the emergence of motion capture technology and the evolution of render elements, which are basically just using 2D pixels to represent 3D spatial information, it completely altered the compressibility that virtual architectures were able to depict and pick up. So together, these elements and all of these changes in the history of CGI are what Warburton kind of calls the cumbersome, it's cumbersome CGI images, which he regards as a hyper image, or he calls the exploded image. So, and he breaks this down as the computational image deals with two specific factors. And one is computer vision, and that's the way the machine interprets how to see the world. And the other one is computer graphics, the technical ways that the machine simulates the world. So if you think a little bit back to the deep dream generator, that's kind of what was happening there as well. One was how it's seeing the world, and then the other side was kind of how it's showing you how it interprets the world. So in a way, this can kind of be seen as what a writer and a curator and a director of the Netherlands Architecture Institute, and his name is Al Bauman, defines as a hyperarchitecture. And it results from this kind of emergence between this physical and this virtual domain. So essentially, it kind of really comes down to this notion of what is happening between the real and the virtual, of what is coming out of the virtual image and then what is going into the virtual image, and what that kind of hyperarchitecture is doing and how it's influencing us to an extent. So, sorry. And then this is a still from the psychometric. Sorry, I had a note about it. But essentially in this RGB FAQ, he's trying to map out what the mainstream narrative of the CGI image is. And then he usually, in his other work, is trying to kind of critique it. So in this one, it's psychometrics kind of deals with the way in which we are mathematically, numerically obsessed with progression and statistics and all of these kinds of things in modern society. So one example also that you can kind of see the feedback of this training of the motion capture is in this artwork, Mutations of Presence by Saojin Chung. And so if you look over there, you can see that that's the way in which the robot is learning to see how she moves by the anatomical feature. And then what she's doing is she's creating this collaborative painting with the robot, and they just feed and kind of do this feedback with one another and create paintings like this. And so the last part is the non-human collaborative space that I'll talk about. So this is a work by a Dutch media artist and its experimental filmmaker, Joost Rekveld. And he kind of found that most neural networks that people are reading about in scientific papers were much smaller compared to the number of pixels in high resolution images. So he kind of tried to look to find a more detailed description of how neurons behave and applied it to pixels. And he found one called a Fitz-Hugo model, I think, Hugamo model, which shows how nerve impulses propagate when used in an assemblage of connected units. So he kind of created these universes of control, which have features that afford this kind of artificial life to grow in ways that are not necessarily under his control. He calls this process a dialogue with machines, which quote the process of mutual co-construction of media artists and their tools and artistic languages. So the output of this particular dialogue with the machine is the work number 43, which was a vertical cinema work, which you can see over there how it was exhibited, which resulted in this kind of emergence of a style of fractals, deemed like a cybernetic psychedelic style or something, which is interesting because the digital emergence of fractals kind of only arose in the 1980s with the computer's capacity for these iterative processes that create visual repetition with change. So it's kind of only with the iterative power of the computer, the algorithm, that one can visually reproduce the fractal equation as it also appears in patterns in nature, like the Fibonacci spiral and forest ecosystems and lightning patterns and neurons and much more. And so this kind of begs the question of where the natural environmental patterns and those delineated to the objects of the mathematics and technologies begin and extend their edges and or end. Also, kind of the implementations of algorithms kind of haven't only extended their network edges in that way, but also have embedded themselves into kind of all forms of our contemporary human experience, perceptions and actions, like the way we work, the way we perceive, the way our minds work, who we are. So like today, it's common for humans to question what networks they are or are not a part of, what information sources does one include in their narrative and their experience, and to what extent does this kind of sensorial experience play within these information networks of human, non-human collaboration. And also as a feedback of our emotions and decisions and movements and habits, we leave these kind of digital footprints harvested within the algorithms to generate the value that we give them. And so kind of taking a little bit more of an eco-political stance, but kind of also exploring these shared spaces with the non-human is the French filmmaker and media artist Jacques Lecointe. And this one is before the collapse of Mont Blanc, and it directs one towards kind of this presence of a human tendency to numerically process within complex technological systems or matrices or vectors. And Lecointe says, quote, call it urbanization, global warming, nuclear testing. We ask for answers while proving the numbers of an algorithm that we can't control. So kind of through this collaborative human, non-human composition and assemblages, Lecointe kind of distorts the notion of the pixel and instead bleeds it into and within a perceptual representation of a natural landscape. The way he films is in a way to kind of let the actions of the natural life forms take their course through the composition of having fixed shots in these natural spaces, and then finding the right spot to place the camera and then leaving it there, which essentially can maybe be considered in the way in which one would design an evolutionary algorithm, is designing the algorithm, putting it down, and then letting nature kind of take its course. So, but after he brings his footage back to his work studio, he's essentially kind of viewing the content for the first time. He uses these compression techniques, which are performed by the algorithm, to try to find this perfect stance by way of a segment. So he kind of crosses over these aesthetic domains that manifest and transform to this social construction of reality concerning this conceptual distortion of the space versus the place, or the real versus the virtual. So Lecointe kind of co-creates with the machine using these compression techniques as a way to visualize the infrastructure of the image, as compression causes these very important changes in the internal organization of the video file. In this distortion, the traces of the mathematical operations used in order to save memory space or reduce information kind of become exposed to him in that process, allowing Lecointe to discover what the variations and the expressions of force of these kind of video chromatic deformations. And this kind of pixelated fragmentation produces this kind of trance, which brings an additional layer of an awareness upon kind of these collective aesthetic ideals that are attributed to either nature, such as the movement in water, or those attributed to the digital pixels in visual technologies. So he kind of effectively, by not adhering to these aesthetical hierarchies of demarcated lines and objects, the visual kind of pulls the viewer out of the binaries that are associated to those, and then kind of out of these realistic temporal parameters. So blurring the pixel coordinates kind of leads to this disjointed spatial coordinates, making the viewers kind of think also to themselves, where am I? Where's everything else? And trying to find ourselves as a data point in this space. So I kind of just want to end where I began, to come back to the same artist for Anadol, which and think about his work that deals with AI in relation to all of the other angles and insights contributed of the other artistic practices. So this one is called Quantum Memories, and it was made with Google AI Quantum Team. It was inspired by the many worlds interpretation in quantum physics, which is a theory that holds there are many parallel worlds that exist in the same space and time as our own, and used in quantum research data and algorithms to exploit what they kind of deem as this aesthetics of possibility. So the question they posed being, what would happen if another machine or a machine like AI looked at these patterns of alternative dimensions that exist in the bit strings of quantum computation? And to try to answer this question, they trained a data set of 200 million images consisting of images of nature, and then let the AI find the patterns in the string and transform that quantum noise into a latent space exploration. So kind of looking at how then does this process of using images of the natural landscape, say, compare to Percont's use of images of the natural landscape? So you can essentially see here that these are the images that were used, and they kind of are static, discrete images of the natural landscape. So how can that be compared, say, to Percont's filming, as they're not necessarily filmed in motion? And then as in the exhibition, the work kind of provides an interactive aesthetic experiences as well by tracking the audience movements. How can that then compare or relate to Saugen's methods or Warburton's CGI commentaries on the history of the motion capture? And then moreover, Anadol kind of explains how this interactivity is reconfigured through this immensely large-sized installation piece, which is aiming to confront viewers with the scale at which they exist as a data entry point in this space of the machine learning. So he says, like, to quote, find the human in the non-humans. Then how does that then relate to the ways the other artists have aimed to showcase the person as a data entry point? And do we necessarily want to see ourselves as a data entry point? And so then, or is it just necessarily kind of a reconceptualization of a white cube model that's like displaying a contemporary art as a studio or experimental laboratory, showcasing these kinds of works in progress or works of art in constant flux? So to conclude, it's kind of thinking of how have new media technologies changed our conception of space, whether it's the museum space, the urban space, real or virtual space, non-human space, or spaces of the mind. And then kind of thinking about the ways in which relationality and relational sensorial perceptions could perhaps be seen better as a definition of processes of creativity between these kinds of human, non-human assemblages and cohabitation. And then also maybe thinking about the ways in which we see and place and value the world is based upon how we frame them, and that the visual and the spatial perception between the human and the non-human, and how disorientation of these like perceptions and the compositions of the human and the non-human, or the visual screen, can kind of give us a little bit more insight on how we have these kind of perpetual indexing that goes into machine learning creativity or AI creativity. So yeah, I think it kind of just brings up, and that images kind of serve as entry points into this kind of other diagrammic layer that Warburton showed, of these render elements, or this long history that everything that we are putting on the computer, or all of the CGI artists that are creating all the massive strides in Hollywood blockbusters or any kind of computer graphics, are feeding into the ability for these machine learning models to kind of succeed. And then, so where do we want to stand as a data entry point in this kind of new form of creativity that's happening with AI and machine learning? So yeah, and those are my, we're excited, and so thank you. Yeah. Oh yeah.
Okay, do we have some questions or comments?
I have a question. Thank you. Really intriguing works, I think. I have actually two questions. One is on the processes of creativity. So now, instead of focusing on the artwork that's the result, it's about how. So do you mean the process of the artist interacting with the machine, or do you mean the visitor? So where is the creative process? Is it in the making of the work, or is it in the viewing of the work?
Well, that's the thing is I think that what it shows is that it's kind of both essentially. So if you're thinking about it in the museum space, it's whether it's with the Philip Parano viewing the screen, or it's with Anadol, which actually does deal with feedback that moves the shape. It's you're involved in what's happening with that. And I think also with what Warburton shows, or kind of a lot of the studies in new media, is that everything that we're uploading on Instagram or on TikTok or Facebook or any of that kind of data is then used to feed the models in which these artists are then using to create these AI artworks. So it's this kind of feedback between the two. And that's why there's this kind of, I put the slash of the real and the virtual space, because it's kind of going back and forth between the real space and then back into the virtual space and then back into the real space. And it kind of just feeds one another. So it becomes this kind of co-creativity, but not necessarily of just the human artist and the machine, but as a entire assemblages of whether it's nature or people, or even with the MoMA artwork, that it was using all of the past artworks in order to create this new one, that it's kind of transcending these spatial temporal parameters. And that's what creativity has kind of become with AI creativity, I guess.
And the other question is for me, so to what extent is it clear what you're looking at? So how much contextualization is necessary to understand really what? So you talk about how it also changes our own relationship to both, say, real space and time, but also the image, the images of it, and the processing of that. But it's also just in the end, something colorful and attractive to look at.
Exactly.
So to what extent is it really? Yeah, is that happening?
That's the question, right? I think that's also why I wanted to show a bit of like Joost Rekveld and Jacques Berkant, who are, I mean, Joost in that case was using generative algorithms to create the fractals, but most of the time doesn't normally do that. And Jacques Berkant doesn't really use AI or machine learning, but kind of creates a similar aesthetic and also changes, does a kind of collaboration between technology and nature. So it's kind of bringing this question of, do we necessarily really need these fancy looking works? What are they actually doing? Is it something that kind of creates a visceral contextual lesson, or something that we want to think about and learn from? Or is it just because it's, the new thing? And actually, the artist Jacques Berkant, he also says that he thinks that it comes down to the fact that gallerists are asking for generative works instead of video works, for example, because they're more exciting. And in his view, that's kind of where people seem to be a little bit more obsessed with the novelty of having seen something that they think is constantly going, even if they aren't going to view it. They want to know that they saw something that was an only once time happening, even if they're only going to stay there for 30 seconds, rather than viewing the actual maybe 5-minute long video that's a loop that everybody else can see. So I think it kind of makes this question of, do we really need these models? What are they doing? And then, can it be done with older technologies? Do we necessarily really need to throw them away? And I think the image is an interesting place to look at that, but it then does become complicated because you have it in different formats, and you also have it with the real and the virtual and all those kinds of things. So yeah.
I
a similar sort of question. So I've been live tweeting and therefore searching for presenting about, and I'm surprised at how many I just find directly on video. And so you talked about the gallery space, the music space, but is it to be just looking at on your computer? And in one case, well, two cases there, one case there was talk of NFT, another case, like inquire, and that would send an email to the office. So that particular work of art is not available. And my understanding of NFTs is that you can decide whether or not people, or you can't. Anyways. So
I don't know, actually.
yeah, those different spaces, but also both public and private.
Yeah, no, I think that's an interesting question and point in terms of like, what is the difference actually between going and viewing the works in person and then just kind of looking them up on your computer right now. I think that's like the case for most works as well. First of all, for like Jacques Bricant, his are also very huge images, and it's very different viewing it on your computer than it is there. I do think that the one that you were talking about, the Inquire, is unique, maybe in the artist's intent at least. I wouldn't say that I necessarily agree with this, but I think for the artist's intent, it's to try to kind of like place yourself in the environment of a physical algorithm so that you kind of like feel the slowness of it and that your feedback is included in it. And then that kind of grounds the algorithm in something that you can, is in your physical space because you're kind of sensing it. And then for the Refik Anadol, the NFT one, I'm still not even quite sure how that one works. It just came out because it's at the MoMA right now. So I think they're making screenshots of that and then selling them as NFTs, but I'm not very sure. I don't know how that one works. But yeah, I think it's a really interesting question for sure of what really is the difference. And it's interesting to see it go more towards the ephemeral kind of only this person can have this one NFT, or versus everybody can go and view it in the space together or things like that, or you can inquire to buy it. It becomes a lot more elusive and a lot more, VIP or something. But yeah.
Yes, so I think I even know you will answer. I think I certainly know what some of the artists will answer, but I really seized on a technique you mentioned in your very first slide called UMAP. And where UMAP intersects with my life, I would say the most common scenario is one of my students comes to me, UMAP is a fun technique, you get a pretty picture out of it, and they immediately want to do the natural thing, which so this is what I think the x-axis means, so the y-axis means, and I always have to pop bubble and say a disadvantage of UMAP is that although you get a pretty picture, like this space is completely meaningless, distance is completely meaningless, all it can do for you is put things together that may or may not be something like cluster. Like it's a good starting point to help think about your space, that's it. But then when you put it in the context of I'm making new art with this, I would find it much harder to be grouchy and much less willing to just pop up and say, well, this isn't really a manifold, so you can't use it. I mean, why shouldn't you use it if it gave you, an interesting idea? And so I just wonder if what you see trends are like how far can we abuse technology, I guess? How far can we abuse techniques if it gives us a result that's pleasing the public? Does it matter? I don't even know the details of how that maybe UMAP was used in a way that made sense there, but does it matter if one of the algorithms was used in a sort of statistically nonsensical way in the artistic process, if in the end we've produced something that is, let's just say desirable or aesthetic by other properties? Can we let go of it completely, or does it still matter?
Well, I think like there's two things there, and one is it's interesting in this case of kind of knowing that it's the UMAP algorithm because of the way that it's structured. So you kind of, if you know what it looks like and you know what it is, then you kind of can see the hack that is what that image is doing in a way. So it's helpful if people know what they're looking at, and then it's maybe not as magical and as special. But cool. Yeah, it does look cool though. But and I think that to the other question in terms of to what extent can we exploit these technologies just like, for novelty, not even necessarily for anything that's specifically scientifically meaningful or something like that, is kind of just, I think it's nice to go back in technology and see the ways in which artists have done that with different kinds of technologies. So maybe static in a television or using, so I think in that way it's okay, right? You can exploit these technologies creatively, and that is creative, but that's why I think it's helpful to know what exactly, how is that work being created? And if you know what the UMAP algorithm is, then you can take your guess on if you think that that's an exploitation or you think it's maybe a trick or a cheap trick, or, you don't know. So, but yeah, that's what I would say.
I'd also like to ask a question. So what, I like all of these examples, really amazing. And I have lots of thoughts, but so the examples you showed us kind of all follow the pattern, I think. Let's take something from science or engineering and make art with it, right? So do you know of any artistic practice where algorithms are, or AI or whatever, is being built for art and not kind of transferred from an academic setting? Because it's always like that, right? Oh, there's this new cool algorithms, let's play with it, which is totally fine. Right, but I was just wondering whether there's actually work being done in, let's make a creative AI, a really creative AI, not just abusing or using something from somewhere else.
I would think, if anything, it would be more like robotics. I think these days, like the engineer and the artist are really starting to get more and more merged. And I think maybe robotics would be interesting to look at, because like plotter, like creating specific kind of plotter arms. But I also would maybe argue the quantum memories one as well, because I think that they were trying to do specifically like create something that was like a denoising algorithm, because quantum research is just so much noise. It's just like brown sludgy noise. So to try to get it into these kind of colorful patterns, I think they had to manipulate it in some ways that wasn't necessarily done scientifically. So that was
again, that's
specifically
not
for
problem, right? That's super
Well,
useful
yeah.
probably for other
But isn't
denoising
to make it
contexts.
like look nice, and it wasn't for a scientific purpose, I guess.
No, I guess it depends, of course, right?
Yeah.
But I could imagine like denoising is a very useful technique for
Yeah.
I don't know, physics.
Yeah, but I think in this case it was because it was like the quantum research. If that went more, I don't know the specifics of why, but it's more difficult to denoise it than other. But it's an interesting question, yeah.
Let's get back to your question. I think something along the lines of style transfer is more where the focus is artistic. So transferring with Google Deep Dream, I think it's like taking your holiday picture and making it in the style of Van Gogh, or I think that's more work along the lines of creating AI that can somehow be artistic.
Right question, then.
Yeah, no, but I like the example because this is kind of useless, right? I mean, what's this for? Except it's fun to do. So that, it's a good example.
But on that note, I feel like also like in the space of like, gosh, is it art? Is it not? But it's certainly designed for artists. And when you think of, I don't use either of these tools professionally, but like either Photoshop effects or in like an audio production, library not used in a music studio, like a lot of these effects that are used now include a certain amount of AI in them, and these are designed specifically for artistic purposes. They still are very much tools. It feels a bit weird to say that again. It's like is denoising creative. But yeah, it doesn't feel like the right word, but it certainly can be an important step in a creative process. But I think we're seeing more and more AI in those like the tools that artists use in different. When does it become creative? I guess that's.
Okay, so thanks again, Megan.
Yeah. Okay, yeah.
The online crowd is quiet. Right?
Yeah, I keep track.
Yeah. Maybe you can use the time to get tea. So it's getting a good shape.
Last time, let's see if I do. Yes, and then wait. Screen. Here. We good? On point of rules.
Give them 15
Yeah.
minutes. Such more than 20 minutes. Okay. Yep. Yeah.
Means that we need to find things together. Zero.
Okay, so then welcome our finance speaker, Ksenia Fedorova. She's a university lecturer at the Center for Arts in Society at Leiden University. She holds a PhD in cultural studies from the University of California, Davis. That's if I look right, as well as a PhD in aesthetics from University of St. Petersburg. And today she will bring yet another perspective to the table. We had already a lot of talk about machine learning and AI, which I think also figures prominently in your presentation, but also something we haven't heard so far, namely analog computing. So it should end computational aesthetics beyond the human. So welcome, Ksenia. Thank you.
Thank you so much for the introduction and for the invitation. So I'm totally new to the salon, and so also must say in advance so that this is really work in progress. So I understand this is the one of the purposes of these meetings. So I don't have any written paper. So like Megan did a wonderful job really presenting the pieces, but also analyzing them right away. So I also have about 4 artistic examples and a philosophical framework, which both in a way are a bit new to me. So so I'd like to maybe give you a little bit of a sense where I'm coming from and where I'd like to go with this. With this type of thinking. So I cannot even call it a project yet. So I will welcome feedback very much, and I guess it will be kind of creativity on stage. So thinking in the act. So bear with my kind of thinking out loud, please.
And that's why it's called a salon. It's like this French. So feel.
Yes, and also
very welcome.
The last one. So well, talking about the pieces may take some time, but then really open also to the discussion of all the issues, and will try to do that myself already. So yeah, indeed, just to introduce myself a bit more. So I've been specializing in different fields having to do with both media theory and indeed aesthetics, so the philosophical tradition studying perceptions within mostly continental philosophy. Lately, I've been really focusing more on media art and art technology science. relations. The former dissertation, the book was really on the issue of interfacing. So today, to build up on Megan's some of your last points, I'd like to also talk about this topic of computational real creativity as so perceived by us humans, right? So that it is a type of intelligence. And I will talk about that. So other than human, so how do we go beyond human and where exactly? So on the one hand, it is indeed the computational as concerned with computing technology, the digital, yes, but I also want to engage the analog and kind of address intelligence in that broader way. But since I do want to talk about the aesthetic dimension as well, so and also through artworks, I want to mention this background story of mine, so to do with relationality and sensing, and so really exploring so what it means being in relation. So, well, in this book, I wrote about, well, mediation of basically our being in relation with oneself, with the other, with the environment. So, and in this case, I guess it's also being in relation with intelligence, so different types of intelligence. And so where I'd like this whole story to go is also having to do with representation of decision making. So that's how I am conceiving that, so it's not just about intelligence, yes, but we can kind of focus that on this concrete operations of well, just deciding, yes, making choice, yes, and in a way, so this is what programmatic operative thinking that Christoph was talking about at the beginning is about, yes, so that we have all these functions, yes, commands that really operate a certain process, yes, so something happens after that command is implemented. So what if we consider so the two planes of that kind of operativity, so the abstract one, so the digital, obviously, which is also connected to symbolic language, for instance, connected to formal logic on the one hand, but on the other hand, the hardware, yes, so the analog computing that I'd like to focus on, and of course the interfacial layer of that, yes, so that people can relate to, so forms of representation. So sorry, it's not really on the slides what I'm talking about now. But in the description I mentioned that I'd like to refer to philosophical work by Beatrice Fazzi, or Beatrice Fazzi, yes, so she's Italian. And so she worked a lot on the idea of contingency and computational aesthetics. I'll get to that in the end, but I just want to announce or just repeat what I had in the abstract, so that so her work inspired me to think in terms of computational aesthetics beyond human cognitive representations. Yes, in a way, so she explores this layers of indeed abstraction. And she really focuses on the formal, so the digital as indeed consisting of mostly formal operations. But at the same time, so as a philosopher, she wants to discover the aesthetic dimension within that abstract world, right? So, and in a way, my interest here is to kind of use her framework and yet engaging at the same time, so not only the abstract, yes, but the more tangible, so the analog, and see, so what kind of also, well, I will use her word, kind of aesthetics beyond human cognitive representations we can discover. Well, let's take it step by step. So speaking of decision making, and also like as it was announced, so our tragic presentation. So I sent this picture initially for my presentation, which is an artwork by a Russian group, Where Dogs Run, which is one of the most prominent ones, or at least oldest ones working with art and technology, also quite sophisticated scientific issues. Groups over there, and so it's about kind of decision making and representing it, and yet the agent here is a mouse running in a maze, so a classical kind of cybernetics case. Yes, so checking. Okay, so this ability to make decisions, to compute in a way, to, or at least think. Yes. So maybe here the concept of computing is indeed too long a bridge, but yes, that's why I preluded and still kind of preluding what I'm talking about. So in a broader context of talking about thinking, intelligence, yes, so not just computing, but let's say artificial intelligence as a type of intelligence, yes, and then what types of other types of intelligence can we engage? So, for instance, biological systems, right? And what's going on here is that so there are these two layers. So there is a real mouse. In a real maze running around, and yet its movements are controlled by a virtual layer, which is presented on the screen, and that layer controls, in a way, the physical environment, the real context of the real mouse, because every time a mouse faces a decision, basically, so an intersection, so it has a choice. And so although for her, it in reality, it will eventually become only one direction, yes, in the sphere of the potential, so virtual, it can be also, three other ways, or two other ways, or she can also go back, for instance. So these potential decisions that the mouse is not maybe making will be represented on that screen, and in the real maze, the barriers will close those potential ways for the mouse. I mean, it will start turning somewhere, and then the other ways will be closed for it. So this is for me an illustration of indeed this kind of dialogue between the real, the virtual, right? So the potential, the actual, and also kind of this physical manifestation of this interaction between the two. And since, yes, a biological species is involved, right? So kind of this natural, but other than human intelligence. So it's also interesting to think of also contingency, so indeterminacy. So like we as humans cannot fully, we can in a way predict, yes, but not to an extent of, okay, how long will it take the mouse to make that decision? So in the end, the mouse chose just to sit in the corner because, everything will be blocked. Like why waste the energy and to run around? So they can just enjoy themselves sitting and resting. So so certain things we can predict, but certain not really. But the context for me here is not only the kind of intelligence of other species or living matter, but also the analog in a sense of matter in general. And here is another example of an artwork, which is a performance by a German artist, Ralph Becker. And he is experimenting here with the idea of, a soft machine, as it's called. So it's an electrochemical algorithmic machine performance that probes an alternative computational and technological material regime, inspired actually by Gordon Pask's famous British theoretician, experiments on electrochemical learning mechanisms. So what we have is, it's maybe not that easy to see, but there is a setup where the artist is playing actually with this well, actual petri dish, so in which so this liquid metal alloy is placed in a solution of sodium hydroxide and is stimulated by electrical pulses through a set of electrodes. So it's over here, so on the right, where the petri dish is also being watched by the camera, and this is what people see on the big screen. So, and what they see is basically the process of self-organization of that chemical substance, right? So that it reacts on the electrical impulses, and the performer just well plays with these reactions. Yes, so like how much input the artist wants to give. Yes, and then the system will do something. So which again is hard to predict. Yes, so which is contingent. And so again, it is interesting that it is a type of dialogue. Yes, so between the performing artist, yes, and this well, agent, a partner in this sense, which is just a natural substance. Another type of also substance which can be put in a petri dish is a living one, and that has been inspiring for well, not just artists but also computer scientists interested in unconventional computing. So there is a whole field like that, so which is biocomputing, essentially with slime mold. So some of you might have heard of these experiments. For me, it is frankly still a new terrain. And so I just find it indeed inspiring and see that there is something there, but I cannot really talk about what it gives to computer science, unfortunately. So only in a very general sense for now. So this is a slime mold called Physarum polycephalum, which is an acellular slime mold. And why it has been so interesting for people, because it doesn't have a centralized brain or memory storage, and yet it exhibits behavior that can be still called proto-intelligent or cognizant. So it can solve mazes, can compute shortest paths in networks, and scientists, like computer scientists, have used it as a working model for decentralized modes of organization. And so Sarah Grant and Selena Savic, I assume she's Slovenian, so must be Savic. So they are, well, both artists, but also engineer. Well, Grant is a little bit of an engineer as well, so creative practitioners, so we'll say cultural scholars as well. So they played with this substance to also discover how they can serve as metaphors for telecommunication networks, and how then they can help to investigate communication flows, to see like literally how resources are shared within a network of interdependent nodes. So they come up with this setup, so 9 experimental designs of network topologies to observe then how communication models made of slime mold evolve in different instances of the organism, driven by different conditions of for cooperation, like decentralized, scattered scarcity. So like what you're looking at is pieces of well, food, or the opposite of that, so something that will provoke them to repel. So like honey, they would go for it. So sources of well, sugar, for instance. Yeah, so centralized, decentralized systems. And this is what they observed in the end. And what I'd like to emphasize here myself is that is the process. Yes, so we already raised it up. So is creativity in the end product or in the process? And what I think is fascinating here for computer scientists is really the how decisions are being made. Yes, so not only the end result that well, there are probably reasons for, well, pieces of that brain, yes, if it's still one brain, but many branches to it, yes, which explore space and collect all this needed food. Yeah, so maybe there are some obstacles on the surface or whatever, so in the solution, so it may be kind of predicted or calculated, but still, so not to a full extent. And there is, a lot of kind of natural room here for this organism to go its ways, yes, and then to show us humans how it thinks, yes, which we just don't know before we look at that make some sense of that. And so there have been investigations into this done by Andrew Adamatsky. So he's been one of the key proponents, pretty adventurous person, so and passionate specifically about Thesarum as machines, right? So as computing machines. So he's a computer scientist and indeed approaches it through problems existing within computer science itself, yes, and then looking at this material as presenting new types of solutions, right? So the how is what matters. And yet, already mentioned, how to make sense of it, not only in terms of computer science, yes, but also in a broader one, right? And this is where artists come in. So it will then again have to do with the problem of communication between us as one type of species, our intelligence, yes, the intelligence of, well, in this case, the slime mold, intelligence that computers may be representing, yes, so as just pure logic, this level of abstraction that Beatrice Fatsby is exploring, so the digital, right? The communication between these different domains. And the next and basically last example, which does have to also to do finally with AI proper, so is in fact about interspecies communication, as its central point. It's a work by Helena Nicanole, Word Language. And I quite recently, in fact, organized a little exhibition on that project. So it's a sound work. And I don't know if maybe later after I finish, if someone is interested, so I could play that because that is the point. And maybe it also adds another dimension to what Megan was talking about. So in terms of what kind of images, again, representations, yes, interfaces can we have? So visual is one, right? So acoustic is another one. And what was done there is that an AI, so algorithm was trained on the singing of birds, nightingales, some type of them. There are many apparently, and so there are two phases to that project. So like AI generated its own language in a way, so bird language. So based on recognizing patterns of real birds singing. So and then so that is one stage, and another one is when they were put really in dialogue. Right. So, and for the artist, it is indeed the exploration of capabilities of AI, but within the context of biosemiotics. Like, do birds understand an AI? Yeah, like this problem of intelligence thinking is very closely related to what are then the meanings behind those messages? Yes. So how do we interpret that? And so I think this is not for us to answer because we don't really know what birds understood from that AI singing the messages of those fake birds. So, but it is an interesting, at least, challenge for us to, well, first of all, recognize that indeed birds may think something, yes, and they do react. So then it's a huge ethical question usually. So when we presented this work, invited also specialists in animal behavior. And they told us that indeed scientists do, of course, study patterns of bird singing. So it's one of their key agendas, yes, to understand behavior, obviously communicative behavior, and what really drives, yes, so those species, just like with slime mold, to go one way or another. Yeah, and they told us that it's dangerous, yes, so to kind of talk to birds in this totally foreign language to them, yes, because it will just confuse them and will prevent them from like mating and all that, yes, so that you really interfere in a natural course here. Which maybe also good bridge to, well, the ethics of AI, yes, so in a way we'll know about that, right, so about the biases or about that indeed we, or the majority of the population doesn't know how it works, right, tends to trust it too much, yes, so and people also just get, misinformed, confused, and so on. I mean, it's a bit of a loose analogy, but why not? And so just to put it on the screen, so this book by Patsy that I keep referring to, Contingent Computation it's called, and to also conclude and open up maybe for further discussion with these philosophical questions, once again about the aesthetic dimension of computation, and how that aesthesis can help us as humans to relate to this other type of intelligence. So intelligence of either machines, yes, technologies, the digital, or also intelligence of other species. So I kind of mentioned that, yes, but these are her own words. So to help you to orient again, so she says, one of her questions is, what are the limits of an aesthesis of the digital, informed by then the abstractive logical dimension? So we, well, in the continental tradition especially, so tend to think of aesthetics as related to the sensorium, right? To the affective dimension. So Deleuze has been very influential. And then she engages with Deleuze quite critically to rather prioritize concepts spearheaded by Whitehead. For instance, his radical empiricism, so not just transcendental empiricism, but the radical. I'm not going into that now, so don't want to confuse people not familiar with those philosophies. But then, since she does talk about the ontological, I think it's important to think of this dimension, indeed, like on which planes does this thinking, intelligence happen, right? So she is writing about, well, again, the pure logic, the formal, the discrete operations of the digital, but she wants to talk about that in a sense of aesthetics. So, and the reference to Whitehead for her is important because Whitehead wrote about, well, self-actualization. So like this modality of being, in the modus of 0-1, presence or absence. So is also a way of a kind of this discrete unit to kind of actualize itself. Back to my example with the mouse, for instance. Yes, so that is our unit. Yes, and it kind of actualizes its decisions, well, in dialogue with the environment, of course. But yeah, so there are these planes of both abstract, so presence or absence, but at the same time, that is a very physical thing. Yes, so like those decisions happen for that mouse in a real labyrinth. Well, I don't know if this may make sense. to you. So, but yeah, so she writes about a level of experientiability of computation, of the logical quantitative character of it. So like, and that experience for her, it's not even like experience for humans. So how can humans then experience that type of intelligence? Because then we will fall into the, the more familiar to us, let's say, Deleuzean paradigm that, yes, experience is affective, non-discursive, and yeah, something beyond also our cognitive representations. But then she is asking, well, maybe there are also other beyond cognitive representations that don't have to be necessarily, about physical experience, yes, but can also live in that domain of abstraction, so presence, absence, also electrical signals, something like that. So for me, it is, as I said, so work in progress and a bit of an open question, like to go more with her way of really studying the digital and the formal, or to engage also this dimension of the sensible in a traditional sense. Yes, and this is where artworks may be interesting because they are about physical processes, or maybe there are actually no contradictions in those approaches, and maybe there are ways to combine the two. So I'll finish here. Thank you so much for your attention. Thank you. So I stopped sharing. That's how I see myself here.
Yeah. I was thinking in the beginning when you were talking about kind of this predictability and unpredictability and knowability versus unpredictability, that it's kind of like this discussion between the AI and the cybernetics, that cybernetics is kind of trying to deal with these unknowable self-organizing systems, and then AI is kind of trying to deal with like training predictability into a system. And I'm wondering if like, as you've now at the end kind of talked of Fozzie, of this kind of continuous versus discrete, do you think that those two are like contradictory to one another, that this continuous that's usually typically dealt with aesthetics and movement and experience, and then trying to figure out what that is in the digital computation, how do you think that maybe like predictability and unpredictability play into that?
Mm-hmm. Yes, thanks for this question. I think this is exactly the point. Well, for me at least, like, is it a conflict, a logical conflict, for instance, or can they be compatible? And I think even for her, so since she writes really about contingency, but in relation to this, determinate systems in a way. So yeah, it is a question of finding that space of the experience, let's say, so experience ability of that level of abstraction, and maybe looking at the indeterminate within the determinate. So like her later work is on, in fact, deep learning and AI, and obviously black boxes and how they function. So what is indeed the unknown there, so that can allow us to talk about the creativity of those systems. So initially within the cybernetics tradition, so why it was so inspiring, so to get in dialogue also for mathematicians and neuroscientists and biologists. Yes, because indeed we need to check, to keep in check these different types of intelligence, right? And what they can offer to each other. Or rather, not close our thinking about machines, yes, so as being fully predictable. They're not.
So I have a question. So I thank you. Thanks a lot for the talk that kind of rounds up the whole session, because I think these very different examples tie back to something where we had on Christoph's slide a big red X on the implementation, where we actually put things, right? Is it in the human brain, or is it in like in mouse brain, or is it in fungus or whatever that thing was?
Slime mold.
Yeah, right. And so, and that made me think whether, and that's maybe something I would like you to comment on, whether we are here actually dealing with a qualitative difference or not, right? So is it like thinking about creativity, our topic, or intelligence, that it's maybe somehow related? Are these really different things? So is artificial intelligence really a different kind of intelligence, or mouse intelligence, or slime mold intelligence? Or are these rather different implementations or expressions or whatever of a broader concept of creativity or intelligence? That's kind of the direction of my thoughts. Yeah, so.
Well, since I'm not really a specialist in either slime molds or computer science, so I'm kind of the least qualified to answer about the specificities, right? So commonalities or differences, but I would assume that both would be there. So Christoph, you may help me here. So since you started the factor X, yes, story, so that yes, it can be both. So different, and at the same time we can compare them through this concept of creativity or contingency, as I'm talking about here, because we don't fully know, don't know to the full extent, yes, how either of them make decisions or think or are creative.
I had a question to you, but then how do you distinguish intelligence and creativity? Are those the same things to you then, or?
I'm not sure at all.
Yeah.
But I think, I mean,
any intelligence is creative in a way, right?
it depends how you think about it, because sometimes, like at least implicitly, I think we still associate creativity with, I don't know, like mastery of something, or like exceptionality or so, whereas there are clearly creative processes that are very natural. I mean, children are super creative, of course, right? So I think if you think about creativity like an education component, then maybe not, but otherwise I think they might actually be the same.
Yeah, I'm just wondering if like that focus on the output in creativity, like this mastery and genius code, I mean, that's better something for. I'm wondering if, because we seem to move more towards the process. I'm also wondering what role actually computation, which is very output oriented, plays in replacing that output oriented nature of creativity. And so I don't know if that is like something that actually the more we have techniques that actually are capable of doing creative output, styles, aesthetics, or a particular result, how that changes our relation to creativity. This is just really thinking about it, and kind of.
This makes me think of the previous discussion round and the question about, other artists who make their own AIs, yes, algorithms and so on. And of course, they do that. And I would say not only in robotics, but even so for this, only example I had, so with AIs, Ilan Nicanole, I'm not sure exactly. So if you did work with existing architectures, perhaps, yes, but then still, so there is a lot of work and very conscious decisions that need to be made, so by the artist, but in an open way, right? So in a way, so for the output not to be completely closed, right? And then the artists, in a way, are people interested in, again, this factor X, so the unpredictable, yes, so and in the creativity of a partner they're working with, right? So of a machine, indeed. So I think it's really about for opening up to how it works as well. So I mean, artists help all of us, also especially in the humanities, yes, to understand that better.
Yeah, I think it also raises especially Fatsy's work, a very ethical question. I mean, if you, because this discrete thinking in relation of effect is, of course, very problematic for, from a cultural analysis perspective, I would say. So, I mean, it's the whole phenomenological tradition that sort of is sort of.
Yes, and I was following that as well. So writing about, you know, interfacing and affect and all these algorithms of facial analysis and being quite critical about that. And then now, so I'm discovering her work and thinking, she's critical of Deleuze. Yeah, interesting.
Yeah, so I think it's interesting. So it brings us in a very sort of challenging position to I think that's always the debate also more broadly in digital humanities. I encounter this tension, like the discreteness of computational systems and aesthetics, and that somehow runs counter to the continuity that we associate with
But something would be always missing in
what makes us human. Yeah.
Qualitative, yes.
Yeah, fascinating.
Thank you. This is a really interesting discussion. You're reminding me of an article by Simon Frith, which is called Creativity to Social Pack. I suppose Simon's point is about the moments of judgment. You know, he's saying, if you look at Bourdieu, he's identifying a field where it's a set of power relations and it matters who gets to be creative and who makes the judgment about who is creative. And I suppose in a strange way, in the very first presentation, it was clearly an imbalance between the two sides. On the one side, the human, on the other side, there's machine. Well, only one of those gets to decide what creativity is. So, yeah, I wonder that the Simon's article is interesting because he concludes by suggesting that we get rid of the word creativity.
What's his name again of the author?
Frith.
Frith.
Does he offer a replacement?
Well, I mean, he's a very pragmatic sociologist, so he's looking primarily at those places where judgments of creativity actually find.
What I mean is like the copyrighted
and
So if you abandon the concept, which why not? Because it's very complex and complex, but there are still things we want to talk about where we apply this concept. So does you think there is no creativity, or it's not misplaced usually? What's the fundamental?
Yes, I think his argument would be that the discussion is a little bit misplaced and that it's masking power relations.
Kind of very interesting. Yeah, I mean, especially in terms of AI, machine learning, I mean, also looking at which actors are driving just creative AI, just thinking also, in terms of correlations about like what happens when creativity is becoming like computational, like what agency, like because it's an intervention also in a way, in the way that we think we are creative or we act with creativity. So it changes the way we engage creative and so on. I think there is a whole, I mean, also see it in a more political, like economy perspective, you know?
Yeah, but
maybe that's
on the other hand, art always has a material foundation, right? Be it someone who generously hires an artist, or be it Google quantum research who have like the machines to deal with, like, what was it, 200 million?
Yeah.
Yeah, I mean, this is like just, you know, so without this materiality there would be no neither this kind of art, but also other kind.
But I also find it interesting because there was one example I wanted to include, which I kind of did a little bit, but with in that kind of power relation dynamic. So a lot of the times these CGI people, the people who create these computer graphics or CGIs in movies, they don't necessarily get any kind of creative expression. And so a lot of these CGI artists who are creating these kind of ugly aesthetics or outside of that area are doing it, and they are, some of them of which like to gravitate towards AI because it allows them the ability to lose control for a little bit. And I think that that's a very interesting way to look at it as well, because it's also a different kind of power dynamics of the pressures of society. And so maybe this is where maybe a subconscious tendency of wanting to lose control and allow the AI to do something so that you have one less thing to do or something like that. I don't know, but it was interesting thought.
I think we can really now ping pong as we feel, and I don't need to moderate this. Also, please speak up if you.
About power dynamics, I'm just noticing that so many of these things are ascribed to one person, and I have a hard time imagining a single person will do everything, and it all feels so contrary to what I'm used to seeing in the hard sciences, where you have this with a bazillion authors. I don't think that's a good. The single author thing. I don't find it nice to see that in a art.
It's interesting because in Simon's article, Simon takes session musicians in popular music track as his examples of people who have to be creative, and he's got a nice story about it. They have to be creative, but their creativity is not recognized. They're at the service of artists.
It makes me think, it's a bit of a stretch, but in music cognition, as in the past 10 years, there's been really open things up. For many years, music cognition focused a lot of research questions on what is the difference between musicians and non-musicians, with a real implicit kind of genius bias and also completely inconsistent definitions about what it meant to be a musician. And then there was a kind of like psychometrically validated study that really was looking at sort of everyday music sophistication, was the term they used. In some ways unfortunate, in some ways helpful. And now the idea was, I think the article was entitled, if I recall, measuring the musicality of non-musicians, and really trying to make it's a whole scale of what are things that are musically sophisticated in different degrees that everyone does. And I wonder, to break out of this power relation model, or not to break out of the model, to break out of that way of thinking, is that thinking more about it, so like, okay, what is everyday creativity? What are creative acts, that everybody does, that maybe are very, very small and don't make any kind of genius, that are agreeably creativity nonetheless? It might actually also become a very useful way to assess computers, whom we may not, in the end, need or even desire to become genius, expert artists, but to say these are all of the little ways in which we can say this algorithm is creative. The same way we might say the same thing about, your child's drawing, may not yet be ready for MoMA, but in many cases, we'd also say can be quite creative.
Yeah, but I think I'm raised on a diet of Pierre Bourdieu, and so I can never see this outside of the sociology of the art world that values the artist's intent. So I think we have to first get rid of that in order to democratize creative achievements.
I think there's sometimes these kind of surprising examples of creativity where we wouldn't look as like first, like that wouldn't be the first place to look for. So like in the kind of like classical domains, you maybe have some kind of spectrum, like music, for example, between more or less just reproducing what you learn, right? Like you learn to play a piece or whatever or sing. It's not very creative. You don't really bring a lot of yourself into that. And on the other end of the spectrum, you have like very high sophistication, maybe. But on the other hand, stuff like, I don't know, memes on the internet, right? making a funny caption for a picture, or using a GIF as a response to a text message or something, right? Like these are these kind of everyday acts of creativity, which a lot of people do, right? And it's not really where we look in, like, where we would look first, but I mean, maybe it's because this is not so codified, right? Like, because we don't have these super clear standards of like what is good or what is like maybe different levels of sophistication there, that people actually go there to kind of live out their creative urges or whatever.
But I think that kind of supports the point that you always need, like in sociology, you need someone, a curator or an audience or someone to validate it, like to count as a creative product, process, or whatever. I think, and this, of course, the values change. They are probably nowadays much broader than they before.
But if you think about memes, this is something where like the structures are completely different, right? Like there's not kind of one group who gets to decide what is good and what not. It's much more.
But still, you would say, oh, this is funny, and this is just a copy, like this, right? So there is still a value between, like, these things, right?
I would actually venture to guess. So obviously, there's a lot of social context that involves in creating a meme as well. That as we saw in the talks today, could be just difficult or impossible for a computer to know. But I guess even if we could. It's hard to imagine that some sort of abstract like caption for a meme that doesn't necessarily have to be funny or know about current events, but just fits somehow, something more than just the description of the image. I venture to guess that even for like the DeepMindy type tools today, that would still be a very hard problem. I maybe I'm too pessimistic, but I expect that computers would still really struggle to hit a space that wasn't literal description, but also wasn't nonsense, even if we forgave them for not knowing about current events of humor.
Even for humans, it's kind of a show of skill, right? That you can make a funny meme is something that's kind of totally valued, and it's not trivial, right? Or I mean, if it's not funny, then not. But
it's also that to look at it, there's a computer doing one thing, produce one meme. I think we don't look at and you gave the example of creativity being good and being new, being novel. These are things that you don't measure on a point in itself. You measure it in relation to other things. That's what the society is about. And I think you can create many memes, and then out of it emerges a system of how memes are created. And I think it's by focusing so much on the human intent and the individual's intent, I think we might overlook that creativity is not so much an individualized process, I think, but more of an aspect of the system, a culture in this. And that to me also brings in like sociologists, thinking more as a process.
It's also the hermeneutic circle of Gadamer, right? It's the horizon of meaning that things sort of tap into. That's why they are fun. It's quite. So that touches on the problem of context. How do you model and recreate all that rich context? That's culturally
also helps if you don't have an AI system. If you have multiple AI systems surprising each other, then you get this. You can replicate this much more than creating one AI system with a perfect optimized function to do this one thing. I think those are the steps which we need to think. And people are already.
It might be that the word creativity, especially in the computer context, has got itself slightly too much of a charmer. Because you remember that Margaret Bowden says in her definition of creativity that it's not just a question of doing something you didn't do before, but doing something you could not. And that's a really high bar. But you know, your algorithmic chef would cross that bar. So maybe we need to think a little bit about just the common usage charge.
I think we.
Start.
Well, I see that some people have to leave, so maybe it's also good to. Yeah, I know, and also we always go for drinks, so we can hopefully continue this fascinating discussion over drink. But before we leave, so if you have to run, please go. But I do want to take the opportunity to also put Fabian in the spotlight, because you have been with us for a while, but you now found you have left us, in fact. But as I always say, people who work with and in and for CREATE never really leave, because somehow we always know how to find you and keep you in the network. So I hope you will do wonderful things, and please come back to us and talk to us about your own work in computational creativity. We really look forward to hearing that. And yes, you get a gift to remind you of Amsterdam and your time. Thank you so much. That's our work. And let's all go for drinks at Zeppos if you can make it. And if not, safe trip home, and looking forward to seeing you again in January, Melvin, when we talk about
Cultural evolution.
Yes.
I think. Visual creativity.
Small steps, same discussion, so to be continued. Thank you all.